So, you hear a lot about Web3, right? Well, today we're going to pull back the curtain on the invisible engines that make it all work. Smart contracts. They're the silent, automated workers building this new digital world, and we're going to break down exactly what they are and why they matter so much.
Okay, let me just start with a question. What if an agreement could just run itself? No middlemen, no waiting around, no having to blindly trust that the other person is going to hold up their end of the bargain. That one single idea? That's the whole reason smart contracts even exist.
And you can really see the difference right here. On one side, you have the old way, right? Traditional agreements. They're slow, they can be super expensive, and you're always relying on some kind of middleman, a lawyer, a bank, you name it. But on the other side, you've got the smart contract promise. It's fast, way more efficient, and it's all built on this idea of trustless certainty. You don't have to trust a person, you just have to trust the code.
So, why did we even need this big shift? Well, that brings us right into our first section. The problem with people. Or, maybe more accurately, it's about overcoming the human bottleneck. Think about it. In almost every system we use, there's always a person in the middle slowing things down. A lawyer has to sit down and actually draft the contract. A bank employee has to look at a transaction and approve it. A platform has to step in and mediate if there's a fight. Every single one of those steps adds time, it adds cost, and it introduces the chance for mistakes or, someone not being totally trustworthy.
So to get around all that, let's imagine something new. Picture a city, an automated city, a place where the infrastructure, the whole system, runs entirely on code, not on people having to trust each other. This is the world smart contracts are building.
Okay, so let's drop the city metaphor for just a second and get really specific. What is a smart contract? It's basically a computer program that executes itself. It lives on a blockchain, which makes it secure and transparent, and it does exactly what it was coded to do with no human interference. The keywords here are self-executing and unstoppable.
You know, the best way to really wrap your head around this concept, the absolute simplest analogy, is something you already know inside and out. A simple vending machine. Seriously, it's like a perfect little real-world smart contract.
The logic is just so simple, isn't it? You provide an input, your money. That's the condition. The machine then checks its one rule. Is the amount correct? If the condition is met, it executes the agreement and gives you your snack. If not, it just rejects the whole thing. There's no negotiation, no trust needed, just pure automated logic. That, in a nutshell, is how a smart contract thinks.
Okay, so if that's the what, let's talk about the how. How does this whole automated city actually run? Let's pop the hood and take a look inside the engine room.
This idea didn't just appear out of thin air. Way back in 1994, a computer scientist named Nick Szabo first proposed the concept. Then, fast forward to 2019, Bitcoin comes along and proves that, hey, these decentralized networks can actually work. But it was pretty limited. The real game changer was in 2015 with the launch of Ethereum. It introduced a programmable blockchain, kind of like a global computer that could run these complex smart contracts for basically anything you could dream up.
So how do they actually operate? First, they don't live on one person's computer. They run on a global decentralized network called a blockchain. That's what makes them so secure and transparent. Second, they don't just run on their own. They have to be triggered by a transaction. And finally, every single action requires a small fee, known as gas, to pay for the computational energy the network uses.
Now, for what is maybe the single most important rule of this entire system. You have to get this one. Once a smart contract is deployed to the blockchain, it is immutable. It can never, ever be changed. Think of it like carving an agreement into stone.
And this immutability, this can't-be-changed feature, is a classic double-edged sword. It's a massive trade-off. The strength is obvious. It creates absolute trust because you know for a fact the rules can't be secretly changed on you. But its weakness is kind of terrifying. If there's a bug in the code, that bug is also permanent. Mistakes can't just be patched.
And that brings us to the central tension of smart contracts, their incredible brilliance versus their profound fragility. So let's look at a tale of two very different days in our automated city.
First, let's look at a smooth day. This is when the system works exactly as intended, creating efficiencies that are just impossible in the traditional world.
On a good day, you see DeFi protocols automatically generating yield for users without needing a bank. You see NFT marketplaces preventing fraud because the contract simply won't allow a duplicate to be created. And you see DAOs, these decentralized organizations, making totally transparent decisions where every single vote is counted perfectly and publicly by the code.
But then, there's the disaster day. This is what happens when that rigid, unchangeable nature of the code gets exploited.
A disaster day is when a single bug in the code, like the one in the infamous DAO hack, leads to millions of dollars being stolen. It's when outside data feeds are manipulated, tricking the contract into making a bad decision. And because the code can't be fixed, those funds can be locked away or just lost forever. There's no undo button.
It all really comes down to this simple, powerful idea. In the smart contract world, code is law. And that law is cold. It doesn't care about your intentions, and it definitely doesn't forgive your mistakes. It just executes.
So where does all this leave us? Let's talk about the future and where this automated city is headed next.
The crucial point here, the main takeaway from all of this, is the fundamental shift that's happening. We are moving from a world where we have to trust institutions and the people in them to a new world where we can just trust math and verifiable code instead.
And that leaves us with one final, pretty big question to think about. If code is truly becoming the new law that governs our digital interactions, who gets to be the programmer?